Imagine you're falling into a black hole. Not slowly, fast. Everything around you is pitch black. And then suddenly, strange glowing particles start appearing. They hit your spacecraft. Sparks fly. Fire starts. You have seconds to react. Now, is any of this actually possible? What would really happen? Let's find out. If you remember, in 2014, Christopher Nolan made a big blockbuster film called Interstellar. In that film, concepts like space, relativity, wormholes, black holes, and alien planets were shown in a very scientific way. But maybe the most scary scene was near the end, when the main character Cooper falls inside a black hole called Gargantua. At first, everything around him is completely dark. Then some strange particles appear. They start hitting his spacecraft. Sparks fly. Fire starts. He is forced to eject from his craft. And then suddenly, he finds himself inside a five-dimensional space, a tesseract, where he can communicate with his past using gravity. After watching all this, a big question comes to mind. Is any of this actually possible? What would really happen if we fell inside a black hole? Let's try to understand this today. The concept of black holes is not very old. Just 100 years ago, nobody even knew about them. It all started with Einstein's Theory of Relativity. Einstein showed how speed affects time. If you are sitting in a very fast spaceship, time will move slower for you compared to people on Earth. You won't feel it, but when you come back, you'll realize time was different. This is called kinematic time dilation. But speed is not the only thing that slows time. Gravity also slows time. This is called gravitational time dilation, explained in Einstein's General Theory of Relativity, 1915. The stronger the gravity around you, the slower time moves for you. This was shown beautifully in Interstellar. On one planet, 1 hour equals 7 years on Earth because that planet was very close to the black hole Gargantua. Einstein said, "Imagine space-time like a mesh or fabric. Heavy objects bend this mesh. The heavier the object, the more it bends space-time. And gravity doesn't just affect physical objects, it also affects sound, heat, and light. This means there could be objects in the universe whose gravitational force is so strong that they absorb even light completely. And if light can't escape, we can't see them. These are black holes. But when Einstein was alive, black holes were just a theoretical idea. He wasn't even sure they really existed. In fact, the word black hole wasn't even invented until after his death, first used in a magazine in 1964 and made popular by physicist John Wheeler in 1967. How are black holes formed? Black holes are formed from stars. Stars like our sun have nuclear fusion reactions happening inside them. This produces heat and light, which pushes outward. At the same time, gravity pulls inward. This balance keeps a star alive. But the fuel, hydrogen, helium, doesn't last forever. When the fuel runs out, the outward force stops, and gravity wins. The star collapses on itself. What happens next depends on the mass of the star. Small/average star leads to red giant, leads to white dwarf. Large/heavy star leads to red supergiant, leads to supernova, leads to if the leftover core is small equals neutron star, if slightly bigger equals black hole. Our own sun will never become a black hole. It's too small. This was proven by Indian-American scientist Subramanian Chandrasekhar, who gave the Chandrasekhar limit. A star must be more than 1.4 times the mass of our sun to become a black hole. If our sun somehow became a black hole, its diameter would only be 50 kilometers, from something enormous to just 50 kilometers. Types of black holes. There are mainly 3 to 4 types. Stellar black holes, most common, formed from stars. Our Milky Way alone may have 10 million to 1 billion of them. Primordial black holes, as small as an atom, but as heavy as a mountain. Still just theoretical. Supermassive black holes, extremely large, more massive than 1 million suns combined. Scientists believe every large galaxy has one at its center. Our Milky Way's is called Sagittarius A star. Intermediate black holes, somewhere between stellar and supermassive in size. No proof discovered yet. What does a black hole look like? A black hole is not a giant black ball sucking everything in. It's more like what you saw in Interstellar. The most visible feature is the accretion disk. an orange/yellowish glowing ring around the black hole. This is because black holes' gravity pulls in gas and debris from space. This material orbits the black hole very fast, heats up to millions of degrees Celsius, and starts glowing. It releases X-rays and electromagnetic radiation. In reality, our eyes can't see X-rays, so scientists represent the disk in orange-yellow color, but the actual color would be closer to blue. The first ever real photo of a black hole was taken on April 10, 2019, using the Event Horizon Telescope. It also showed this yellowish-orange ring, special visual effects around a black hole. Doppler. Beaming. Particles spinning toward us look brighter. Particles spinning away look dimmer. This is why one side of the ring looks brighter in photos. Optical illusion of the disk. Because gravity bends light, the accretion disk appears to wrap around the top and bottom of the black hole too, even though it's a flat ring. Photon sphere. Just outside the event horizon, gravity is so strong that even light starts orbiting the black hole. If you somehow survived reaching this point, you could theoretically see the back of your own head because light is going in circles,